podcast, we're going to go over the 4 different types of formulas that you will encounter in organic chemistry, and we'll talk about which ones you specifically need to learn how to do. All right, so these are the 4 types of formulas that you may come into contact with. If you don't get these written down, they're going to come up on the next slide, but molecular formulas are going to show us the type of atom and the number of atoms. You've seen this before in your first semester chemistry class. Structural formulas show us all the bonds to all the different atoms in there. These guys are really laborsome to make. We don't typically use structural formulas very much in organic chemistry. Condensed structural formulas seem to be the favorite for textbook makers for pre-nursing students. You're going to see this the most. This is a shorthand method of structural formulas. We don't show lone pairs, and we read it from left to right on the paper. Skeletal formulas are used more often by chemistry majors because they really are just the nitty-gritty bones of your structure. It's easy to draw, it's quick to draw, it doesn't include anything that can be assumed. We will be using skeletal whenever we're trying to show a cyclic structure or a ring structure. Carbons are found at the junction of 2 lines, and I'll show you what this looks like in just a few minutes, or at the end of a line. We assume there's hydrogens completing octets. And making 4 bonds around each carbon. And we would include heteroatoms on there as well, so anything that's not carbon and hydrogen. So this is a molecular formula. This is what you've seen before, and it tells us absolutely nothing about the shape of the atom. It's useless to us, but this is going to tell us the type of atom, so I know I have carbons and I know I have hydrogens, and it also tells me how many of each of those. I have 4 carbons and I have 10 hydrogens. Wonderful. What it does not tell me is how those atoms are arranged in space. In a structural formula, we're still dealing with something that has 4 carbons and 10 hydrogens, but now we're showing the bonds between carbons and carbons and carbons and hydrogens. So what we can do at this point is we can say, all right, molecular structure didn't tell me what this looked like in space, but looking at the structural formula, I can see that this is a chain of singularly bonded carbons with hydrogens completing my octets. Again, my octet is 2 electrons, 4, 6, 8. That is a complete octet for that carbon. So these are really informative, but they're really labor intensive to have to draw every single bond and every single hydrogen. All right, we're going to spend a lot of our time drawing condensed structural formulas for our molecules. This is a shorthand method of structural formulas. We're still not going to show lone pairs on here, but it's going to read from left to right, and it's going to be a condensed version of this. So when you're first learning how to do this, my recommendation to you is to go from left to right and draw boxes around your carbons. So here I have a carbon. Okay, this is my first box. This is a carbon connected to 3 hydrogens. Then I'm going to move down to my next carbon. Here I have a carbon with 2 hydrogens. Moving down, I'm going to draw another box. Here we have another carbon with 2 hydrogens. And finishing this out is a carbon with 3 hydrogens. So what I've done is I've taken each of those center atoms, those carbons, and I've addressed specifically how many hydrogens I have coming off each of those. I highly recommend the box method as you're learning this. To work backwards the other way, we have a molecule that's already in condensed structural formula. Here you can see we are showing a bond line, and that is okay to do if you have a branch coming off of, and we will call this our parent chain. The longest chain is your parent chain. So I have a branch coming off of that, and it would be appropriate to show the bond line between those carbons saying, hey, this isn't part of a single chain, this is coming off of it. So if I were to expand this, I always like to start with my longest chain right here. I have 3 carbons connected to each other and 1 carbon coming off. Now I'm going to go back and fill in those hydrogens to make my octet. So this first carbon has 3 hydrogens coming off of it. 1, 2, 3, and now that is a complete octet. My second carbon only has one hydrogen because it's also bonded to this carbon, the branch coming off of it. So this carbon, the second carbon, now has a complete octet. My last carbon in my parent chain has 3 hydrogens coming off of it. 1, 2, 3, and that has a complete octet now. This branch, I'm going to be sure to put my 3 hydrogens on there because I cannot leave any carbon without an octet. I have to account for everything. So as you can imagine, these are very simple and small molecules. If we had more complex molecules, it would take forever to draw all these bond lines and all the hydrogens. And so this is just a way to simplify. So you're going to want to make sure that you're doing enough practice in your guided practice going from structural formulas to condensed and from condensed to structural as you're learning this. So skeletal structural formulas tend to be the ones that are the most challenging at first for students to get. So for our class, we're going to use this more with rings than anything else. So here I have a ring structure. I have carbons that are connected in a ring, okay? And they have hydrogens that are filling out that octet coming off of them. So remember with a skeletal formula, you're just drawing lines and heteroatoms. So I'm not going to include on my final skeletal drawing, I'm not going to include any hydrogens on there. We assume right here where 2 lines come together, so we're looking at this carbon right now, where 2 lines come together is a carbon. Okay, so we have a carbon here, 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 and here, because 2 lines are coming together. At the end of the line, or the beginning of the line, that's a carbon as well. So if we had a branch coming off of here, like that, we would assume there's a carbon where these 2 lines come together and a carbon at the end as well. We don't show the hydrogens because oftentimes that's inconsequential. We don't care about the hydrogens, and it really blocks your view for those complex molecules. So this we will get more practice with later. Let's just review the different types. So what they're not showing me right now is my molecular formula. This is pentane. So pentane is going to have 5 carbons, and it's going to have 3, 5, 7, 9, 12 hydrogens. So that would have been the molecular formula. As a complete structural formula, we draw every single bond line and every single atom that's included in the molecular formula. This is what it would look like as a ball and stick model. So each of those carbons has a tetrahedral shape on it, and that's what gives us this zigzag pattern for our actual structure. If we were to condense that structure, again, we draw these boxes around each carbon, and we'd wind up with CH3, CH2, 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 CH3. We could further condense this, and I don't recommend doing this until later on, but we could say we have CH3 and we have 1, 2, 3 of the same thing. We could say CH2 with a 3 outside of the parentheses, and that means that I have 3 CH2s in a row, but I'm too lazy to write that, and that's okay because chemists are kind of lazy when it comes to writing. As a skeletal structure, remember that there's a carbon at the end and where 2 lines intersect. So there's my 5 carbons, and my hydrogens are assumed to complete the octet.